This is section 6.8. We're graphing some polynomials, looking for some local mins and maxes. It's going to be pretty exciting. Here in factored form, we can identify where the roots or the zeros are really quick. So in other words, what value of x makes y equal 0 when x is 2. When x is 2, y is 0. Also when x is 4, y is 0. So you can plot those 2 points, 2, 0, 4, 0. But then you're going to want to find a value to the left of the first 0, to the right of the first 0. So let's see, it'd have to be between 2 and 4. I'll pick 3. And something to the right of the last 0. So you're finding points in between all of the zeros. So then you just plug them in for x in the factored form, like this. So I'm trying to figure out what y is when x is 0. And you get negative 2 times negative 4, which is positive 8. 0y is 8, which I guess is up there. We do the same thing with 3 and 5. By the way, you can use Desmos to check your answer here, because I'm not going to graph all of these. You get some of the fun. Oops, see my mistake there? I'm plugging 3 in for x. So the second binomial should be 3 minus 4. So I get positive 2 times negative 1. So I get negative 2 when x is 3. By the way, folks, if you were to FOIL this together, could you see that it would be a positive x squared? I don't know what the other two terms would be right now. I could figure it out, but you should identify the shape of the graph. Because it's a positive x squared, I should be seeing a parabola. A smiley face parabola. So once you plug in 5 for x and you plot that point, you should be comfortable with the shape of the graph. It should match what the general template of that type of function is. So here we get 5 minus 2, which is 3, and 5 minus 4, which is 1. So when x is 5, y is 3, according to my calculations. Now, make a smooth connection. Woo. Not bad. Notice how I didn't make a V on the bottom. I tried to curve it. So that's how you do it, folks. So here on number 2, I can find the zeros. The zeros, what value of x makes y equal 0? 1. What other value of x makes y equal 0? Negative 3. Oops. So let's put the negative 3 over here and the 1 further on. So it's like on a number line. So you would pick something less than negative 3, like negative 4. You'd pick a number between negative 3 and 1. Some people might want to do negative 1 because it's directly in between negative 3 and 1. Some people might want to do 0 because it's easier to work with. It's up to you. And then something higher than 1, like a 2. And now, folks, again, when you FOIL this together, your highest degree is going to be a positive x squared. So you should get a parabola upward facing. Now here, if you were to FOIL this all together, folks, you'd have x times x times x, which is positive x to the third. And that shape looks like this. Now there might be some squigglies in the middle here, but in the general, we know that it's going to go up and to the right and down and to the left. That's the end behavior of a cubic function, or anything with a positive coefficient on the highest degree and the degree is odd. So, zeros here. 3 is a 0. 1 is a 0. And x equals negative 1. So I'd put negative 1 here, positive 1, 3. Oh man, you're going to have to make some more space over here, or do some more substituting. Because then, while we know the graph hits the x-axis at these 3 positions, you still need to, I'm going to sneeze. Nope. I'm going to sneeze. Nope. You still need to figure out the other values in between, including to the left and the right of the last 0. I did it. I told you I would. All right, so give it a shot. Find the other values, such as negative 2, 0, positive 2, and 4. Plot the points. Check it on Desmos Grapher. All right. Determine the lowest degree of polynomial you could have. So find out how many zeros there are. There's 4 of them here, so that means that is the lowest degree polynomial that could be given there. How many zeros here? 1, 2, 3, 4, 5. So then it would be the lowest potential is a 5th degree. Could be higher. Here, how many zeros are there? 1. So, I mean, technically you could say 1 here, but it's going to at least have to be a cubic. Because if it was 1, it would be linear. It would be a straight line, and there's some curviness there. So, estimate the coordinates of each local point and state whether each corresponds to a local minimum or a local maximum. So, wherever it curves or turns, that's a min or a max. And so let me change the colors here. The red point is a higher point. Everything else to the left and the right for a period of time is below it. So that makes that red dot a local max. And so it says to estimate where it would be, I don't know, maybe negative 0.8. And the height might be like positive 3 or maybe 2.8. I don't know. But that's a local max. Because it's above all the points right around it. Whereas, oops, I should have done that in red. Now let's switch the colors up. That's the green point. And now, now the blue point is your local min. And so that's, I don't know, at 0.1, comma, I should have zeros in front of these. 1.3 maybe. That's a local min because it's, or minimum, because that's smaller or shorter or lower than all the points right around it. Let's keep going. Number 5, that's a local min. And that coordinate is at 1, comma 2. Here we have a couple of turns. 1, 2, 3. So the blue point is a local min. And its coordinates are, I don't know, about negative 1.5, comma negative 3.8. Again, those are just estimates, folks. Here's a local max because it's higher than the points around it. So you're at 0.2 and 1.2. And this red dot is actually a local min because it's lower than everything around it. If water were moving, it would sink down to there because that's the lowest point relatively. That's at about 1, 1. Last one, graph the following. So similar to what we were doing at the start of this, we can find our zeros. X equals 1, x equals, oops, that'd be a negative 1. X equals 1 here, and x equals 4. So now put it in numerical order. I'm actually going to put the negative 1 here, and I'll do some work right there to the left. When x equals negative 1, y is 0. When x equals 1, y is 0. When x equals 4, y is 0. So I can plot those points. By the way, folks, this becomes an x squared right in here. If you were to FOIL that out, you get x squared plus 2x plus 1. And then multiply that x squared by an x, you get x to the third, you get x to the fourth. So this is a 4th degree. So there are, this 0 right here is actually called a double root. But anyway, I'm thinking it should look kind of like this. Now, because there's it's a 4th degree, it's probably going to look kind of like that, more like a W. But the end behavior will be up and to the left and up and to the right. So you can plot those 3 points, and then again, you're checking a point to the left of that, point to the right of the first 0, in between these zeros, and to the right of the last 0. And then just give a nice smooth connection to all those points. Check it on Desmos.